All right, so we're going to start off with a problem that is based off a situation that occurred that I experienced a while back while I was driving, or rather, I was in the car with my family on the way down to visit some family. We had a breakdown, and it looks something like this here. We have two rest stops at mile markers 15 and 17 on I-95. We break down exactly halfway in between. So, of course, we want to determine, where we were so that we can call for a tow truck and things like that here. So, we know if we draw this out here, something like this, right? And our car, our weird looking car thingy is halfway in between, so we want to determine where we are. Alright, now knowing that we're exactly halfway in between means that these two distances are going to be exactly the same. So one thing we can do here is we can see, wait a minute, alright, so we know we have 27 here and 15 here, so we can do 27 minus 15 to determine this here. We end up with 12, and this 12 represents this entire distance here between the two mile markers. So of course the question is now, knowing that this is 12, we should be able to figure out that these are each. It's pretty clear that each of these is 6, right? So now this is going to be 6 here, and there's going to be 6 here. So that means this is going to be 15 plus 6, or 21 here. So we're at mile marker 21. Now, but Mr. Chung, you may say, wait a minute. There's got to be other things you can do with this here, right? Alternatively, you can think of this as 15. We can think of this, since we're exactly halfway in between, it makes sense it should just be the average of the two. So in this case, this is just 42 divided by 2, which is 21 indeed, and that matches here, right? So it makes sense here that what we're going to be doing, and I think you can show this here in one dimension, that given 2 points A and B, their midpoint's going to be exactly halfway in between it's going to be exactly halfway in between, so it's going to be A plus B over 2. So in 2 dimensions here, it makes sense that, why should being in 2 dimensions change anything here? We can think of each thing independently. So what we have here is something that looks like this. It seems that we can do something like this here, that the midpoint of a line segment, given these two things, x1, y1, x2, y2, we can show that this is the midpoint here. So I'm going to run through the derivation of this, and even though this is technically very intuitive here, I'm going to run through the derivation of it just in case anyway, so that you can see why, why putting these in having the different dimensions actually makes no difference here. So again, we're going to go ahead and plot our points. Just pick 2 arbitrary points. And we're going to do this here. Here's A, here's B, here's x1, y1, and x2, y2. Oh, that's 2 here, and then we'll do that. We're going to pick our point M here as our midpoint, and we want to determine what's going on here. So we know that M being a midpoint here means that AM and MB are going to be congruent to one another. So what we're going to do is we're going to build something very similar to what we did before. We know how to deal with this in one dimension, as long as there is no extra corner to deal with. And the nice advantage of this is that you can construct a line like this. We can construct a horizontal line. When we construct a horizontal line, the y-coordinate remains the same. Since the y-coordinate remains the same, we don't have to worry about it. So in fact, we can actually simply ignore that here, and that changes things, and that makes things a lot better for us. So we can go ahead and do very similarly to what we did here for the distance formula. We can go ahead and construct our points here like this. I'll create a right angle here. Here's C. Okay? So we know that this is the case here. So what's going on is that in this case, here's a C here. We know that this is going to be x2, y1, just like before. All right. So now we need to determine what's happening. In something like this here, we can go ahead and sketch this out here. We can go ahead and do something like this. So notice how in this situation here, in order to find the location of point M, what we're going to do is we want to construct horizontal and verticals, right? If we construct horizontal and verticals, as long as we know that basically this point M can sort of inherit the coordinates from what came from the specific points that came before. So let's look at these points here. I'm going to call these points here D and E. So we're going to start with point D. So this point D here, as you can see in this case here, this point D has a y-coordinate definitely. So we know that it's on the same horizontal line as AC, so it's going to be point y1. Now, knowing that this is the case here, we actually can see quite a bit of this. So this is actually quite nice here. We know that in this situation, you can look at triangle AMD. Let me call this point here E. We can show that AMD and MBE here, right? We notice that AM and MB are congruent. They both have that here. Notice that they both have right angles here as well. right? And we know that this is a horizontal line. ME is horizontal, so therefore it's parallel to AD, so that means these are also congruent as well. So we can actually show, therefore, that we have two congruent triangles here. BME and MAD here, these are congruent triangles here. So that means we have a bunch of these sorts of things. So that means ME and AD are congruent. This is a rectangle here, so that actually forces these two things to be down here. So this, D, must be the midpoint of AC. So we know that this here, based on what we did before, this is going to be x1 plus x2 over 2, right? Because as we saw with the example we did earlier, we had that. So therefore, we can see that this inherits the coordinates. So this is x1 plus x2 all over 2. By the same token, we can do the same thing here. We know that MD and BE are congruent here, these being corresponding sides, and we have a rectangle down here as well. So yet again, we know E is the midpoint of BC here. We know the x-coordinate is x2, and in this situation, just like we did before, now we have only one coordinate to deal with, so this is just y1 plus y2 over 2, and then as a result, this is therefore y1 plus y2 all over 2. So indeed, we can see that this is indeed the case here. This is our midpoint. And note that just like with the distance formula that we'd had before, there's no reason that we need to stick to just 2 dimensions here. If we want to go to 3 or more dimensions here, if we have coordinates that have more, we have points that have more coordinates here, we can just simply stick more things in. So we can say the midpoint being, we can have this here. We can also add a z1 plus z2 over 2 or w1 plus w2 over 2. We can do midpoints in higher dimensions. We can show that it has to be the case as well.